Hello, everybody. This is Paolo Dario from the Scuola Superiore Sant'Anna in Pisa, and I served as the coordinator of the RoboCom project promoted by the Flagera program based in Europe. And I would like to share with you the vision and results that we have obtained within this project that has been visionary and looking at the future of robotics. And I'd like to share with you some slides illustrating the idea of rethinking robotics for the robot companion of the future. First of all, the strategic vision of the RoboCom project. And the strategic vision was based on an historical perspective. So first of all, we experienced as a robotics community what we can define as a grand first wave of development that was based on the concept of integrating within a mechatronic platform. That means a mechanical platform with actuators and with electronics, with control, with human-machine interfaces. A platform that could be used to perform many tasks that were difficult, painful, dangerous for humans. And this is a success story that led to the development of basic knowledge that and to applications to industry. Again, very, very capillary in industry worldwide and still continuing. The second wave of robotics was about what you can call the consolidation of industrial robotics, but also the rise of service robotics. So new ideas, new technologies, for example, advanced mechatronic solutions, the Internet of Things, and software, so artificial intelligence, machine learning were introduced. Europe was a leader in this field, but of course there were also many competitors or colleagues who also developed this. And today, this is a market that is quite well consolidated. In fact, if you look at these figures, it's quite impressive how service robots have established. I would just mention surgical robotics, but I could add vacuum cleaners and or robots for extreme applications such as underwater or in space exploration. So this is also a very successful now area, but and it is now, in fact, is for robotics industry in Europe, but is also in the USA, is in China, Japan, in Korea, and worldwide, and growing according to the forecast of the International Federation of Robotics. This field will explode in the near future too. But there is something that goes after that, and it is very important to create the know-how, the knowledge that would allow robotics to explore and to fully take advantage of what will be the future scenario for what we call the third wave, that will be based on new knowledge, not only the mechatronic platform, but for example, topics like morphological computation, the idea of simplification, self-organization, more and more energy issues, or bionics and bioinspiration, the explosion of new materials of cognitive science, and of course, the total connection to the web. And there are many projects that have been developed on robot companions and essentially on science-based radical innovations involving big initiatives, like, for example, in Europe, Flagship, but in China, also the 2025 program, and so on. And Europe, because this project is based in Europe, is a leader in robotics research. Just look at this scheme illustrating the role of European researchers in publications about robotics. So for sure, Europe is a key player in this initiative. And you can also consider, in the framework of the idea of science-based robotics, the very successful initiative, the new journal Science Robotics, that has got a major impact factor very quickly, showing that robotics for science or science for robotics is a very, very solid and statement. So the milestone of robotics are shown here, very synthetically, of course. So overall, we start from the birth of modern robotics in the 1960s, to the growth of industrial robotics, to service robotics and autonomous robots, to bio-inspirational human robotics, to current challenges like the embodied intelligence. So not only the artificial intelligence, let's say in the brain, but also intelligence in the body. All leading toward the concept of robots for all. So robots that will be our companions in the future. Are today's robots ready for this future? And the answer is no. Those are, example, very friendly made, of course, of limitations of our current robots, because if we want to achieve more complexity, essentially, we are going to have less controllability, less efficiency, less robustness, and ultimately less safety, lower safety. So it's important to do something radical. This is our idea. Of course, mechatronic platforms will develop smoothly, but we want to explore and to go beyond the frontiers of current incremental mechatronic approach. So, for example, looking at a cat, it's impressive how just a simple cat can perform, can have behavior that I define as graceful behavior. That is by far, it's really beyond our capability. So the idea to follow the third wave of robotics is really studying natural organisms and what they can do. So simplification mechanism, not complexity, but rather simplification, the use of new materials, new fabrication technologies, the exploitation of new energy forms is what we want to pursue. And this is exactly what the Flagera RoboCom++ project was aiming at. So scientific and technological challenges, objectives were very ambitious, and I just wish to share with you the strategy. And the strategy is this, of course, we have here an incremental progress of any technology. In fact, but we can talk about robotics technology like a steady progress, and certainly we want to do that. But at the same time, we would like to take advantage of what could be breakthroughs, disruptive innovation that make quantum leaps in scientific and technology advancement. This could lead to an acceleration in innovation. How to do that, of course, is not easy, but the idea is to identify what could be the breakthroughs and to facilitate the implementation of such radical innovation by creating, let's say, a favorable ecosystem in robotics research and also industrial development. So, based on this vision, the RoboCom project was organized and funded by the Flagida initiatives and co-funded by participating countries. And there are a total, you see, of 27 partners with a funding that was in the range of 3 billion euros. And if you look at this, I think it's very, it's a beautiful example of what Europe can do in this framework. Actually, if you look at it, it's really unique in the world. There are partners from virtually all over Europe and also from Turkey, from Israel, from Switzerland. So strictly speaking, not countries not belonging to the European Union, but participating all together as a consortium to pursue the vision and to achieve the results that I have outlined, because only a variety, diversity of knowledge and culture can lead to this ambitious goal. It is very difficult that a single country can do that, because this is a deeply interdisciplinary and in fact transdisciplinary effort. So what are the ambitious objectives of the RoboCom project? Is to explore different aspects, of course, not all of them because of the limitations of fund and time, but to explore the frontier of the robot of the future that will be able to effectively negotiate natural environments, better interact with human beings, and provide services and support in a variety of real-world and real-life activities. And then ultimately leading to a new wave of economic growth in Europe, but of course, if you will, globally, by boosting the deployment of ubiquitous robots and web-based robotics services. And to do that, we have explored and encouraged the dawn of bio-inspired, cognitive, connected, and collaborative soft robot companions of the future. And the unified vision is shown here. Actually, we really want to work on science-grounded robotics to investigate, and this is in yellow, the main or some representative objectives in Robot Companion, and so develop new engineering and new science, and to deploy some applications like a worker companion, a robot housekeeper, and a robot rescuer. We have organized the 47 community members who participated directly and indirectly in 7 working groups that have as a goal defining the roadmap for future global interdisciplinary research program on robotics, but also to enlarge the community beyond the border of robotics. So, for example, in biology, in neuroscience, in material science, in energy, in social science, and in all engineering aspects. And those are just a few examples of the working group. So the first working group is about embodied intelligence in natural and artificial physical agents. And we have identified a number of research topics ranging from computational foundations of action to cognitive architecture, to AI agents for robots, and many other research topics that you see shown here. The working group 2 addressed the soft robotics and bodyware, and the topics were sensors, new actuators, new bio-inspired self-healing materials, new design principle, new evolutionary robotics, and more. And in fact, within this ebook, you will find examples of how these topics were implemented by participating colleagues. A key issue was about energy management in natural artificial agents. This is really, really important and underestimated, in fact, and investigated by current robotics. This is a sort of niche topic, but actually this is becoming in a more and more energy concerned world that we are going to live very crucial. So harvesting energy or storaging or metabolism or design principle for high efficiency, design for disassembling and reusability are among the topics for this working group. And another working group was about embodied cooperative and communication processes. And the topics that we have investigated are about communication, about human-robot interaction, about haptic feedback, shared control, collective behaviors, and topics like that. And then the impact on robotic system technology. So what could be the applications of this new knowledge in, for example, wearable robots, prosthetics, medical robots, but literally everywhere, including marine robots, space robots, humanoid robots, aerial and flying robots, cloud robotics, and so on. And last but not least, really, is about the ethical, legal, societal, and economic issues. This is crucial for the true acceptability and deployment. And the research topics are, in fact, about society, economy, ethical, equal opportunities, education, sustainability. Those are crucial issues, and they represent, taking care about these topics is really a fundamental contribution that the European culture and European researchers can bring to robotics worldwide, and we want to do that. The WG7 is about science platform tools because the idea, the overarching idea of RoboCom++ is about openness. So open source, open science, tools for reproducibility, tools for performance assessment, because this is essentially the science, the fundamental of science. Repeatability and reproducibility are the key issues, and we want to investigate these very seriously. So based on these work groups, we have implemented a number of activities and achieved some significant results. So for example, the pilot project one that was implemented about the computational foundations of actions. This, of course, will be described by my colleagues in the following videos and contribution, but it's about exploring the computational foundations of actions by following an interdisciplinary approach with the aim to make RoboCompanions able to plan and execute daily tasks in an adaptive and robust way. Also, another pilot project is about evolutionary approaches for soft robots exploiting morphological computation. The idea is to demonstrate that computational processes inspired by natural evolution can be used to design effective and adaptive robot bodies and brains for complex tasks and environments. And one important tool to do that was use innovative technologies for building the robot bodies, like 3D printing, but also 4D printing, in which printed structure can evolve as a function of time and exhibit intelligent behavior due to the interaction between stimulus and smart materials. Or also the approach of, for example, in the development of different configuration, like in this case, plant-inspired robots, of course, animal-inspired robots, making use of new technology, conformal electronics. So, for example, ultra-thin substrate ink printable materials, physical or chemical or initiated chemical vapor deposition, dye transfer, water transfer, tattoo transfer. So really innovative technologies. Another pilot project was about wearable and mobile robots. And here again is the goal was to demonstrate the suitability of soft compliant technologies in two different ways relevant for the robot companion. So modeling, simulation, and testing of body movement with haptic feedback, but also the human subject experiment to build an empirical dynamic torso model of user. But this will be described again in more detail. Or again, bio-inspired materials and method for self-healing, and develop these in a new generation of robots. So you can really perceive the importance of body technology that was paid during the project. And another pilot project was about embodied social intelligence for human-robot interaction. Here is more related to intelligence. So, for example, reciprocal recognition of agency, representing others and the environment, integrated cognitive architecture for robots' episodic memory. This is the important also, of course, of cognitive knowledge in order to make robots able to interact with humans. In conclusion, in this effort, we have produced a number of publications, many of them involving a single project partner, others involving several project partners, and also produced some patents and some spin-offs. The ultimate goal of concrete goal of RoboCom++, in addition to generate new knowledge and new technology, was about proposing a big initiative that was part of the FET-Flagship call that the European Union has launched. And Professor Ciclialaschi, who was the coordinator of this initiative, is showing to you how this was organized. But essentially, it was a major initiative with almost 900 participants, 465 institutions, and also a lot of endorsement worldwide. So it was really a huge initiative addressing problems related to not only technology, but also economics and social science. Unfortunately, the project at the end, even if it was evaluated really at the top of the ranking, was not funded. We will continue, we will try in the future to involve many colleagues in Europe and worldwide, as we did, for example, by presenting the RoboCom++ concept and initiative in international conference like Roman 217 that was held in Lisbon, in Portugal, or the participation and contribution to the European Robotic Forum in 2018. We are talking about events with 700, 800 participants from all over Europe. Or at the world level, RoboCom++ organized a workshop that was really very successful from a scientific point of view, asking some of the key historical and current leaders of robotics worldwide. You see here Usama Khatib, Jean-Paul Aumont, Atsuo Takanishi, Hari Asada, Toshio Fukuda, Anibal de Almeida, Yasuo Kuniyoshi, Yoshiko Nakamura, Giulio Sandini, Adam Stokes, and who participated and contributed to this discussion about the grand scientific challenges according to the speakers of the workshop. And you see that most of the ideas that we identified in RoboCom++ were shared by these global leaders. So these dreams for grand challenges that were identified by RoboCom++ belong to the world. Also 2018, we participated at the RoboCom ICT Conference held in Vienna, and we also participated at IROS and European Robotic Forum again in 2019. So disseminating a lot. You see, this is a list of the meetings and workshops that we have performed. And this is my final slide showing all partners. I cannot name all of them individually, but certainly it was a grand effort that we had the privilege of playing for 4 years. And I really look forward to sharing again these ideas and concepts at the global level. So the RoboCom++ project is just ended, but I'm confident that there will be many opportunities in the future, again, to share these ideas about the future of robotics with the global community of researchers worldwide. Thank you very much for your attention.